monitoring, I also look for, because we talked about yesterday about the sediments and things like that. One of the tests that I will run is total suspended solids. Okay? Well, running TSS takes a lot of time. Now, I have a new piece of equipment called a list, which will do it in 5 minutes and give me particle size analysis and stuff. But that costs a bit of money. But anyway, so it takes time to do this. One of the nice things that you can do, though, is there's usually a really good relationship between turbidity and total suspended solids. So if you take enough TSS samples and turbidity at the same time, you can develop a regression equation for that.
It's much like the rating curve between stage and discharge.
Exactly. And so then what happens is I can put a turbidity sensor in my stream and take point measurements every 5, 10, 15 minutes, whatever I want. I just need to calibrate that every couple of weeks. Now I can monitor this and infer what TSS is for a very long duration. If I know that and I know discharge, I can now estimate my load of sediment that goes by in the system. So I can do this much cheaper by this. So this is what I wanted to show you guys. So if you start to do something and you're looking in streams or you're trying to monitor health, like what we saw yesterday, develop this relationship for a variety of flows, then you can put out a turbidity sensor and do this much more cheaply. Okay?
And
so
I can preach about why you need to calibrate, because we didn't calibrate the turbidity sensor. We left out, and what can happen is you have, for example, algal films grow because it's an optical sensor, and so you get a bias in your readings if you don't clean your sensor.
Right. So biofouling is something, very important that you have to do. So look at what the manufacturer recommends and watch the system you're in. If you're in a system with really high algal growth, you may want to do it every week. If it's not so much, you maybe will do less. So you just kind of need to watch that. Anyway, so turbidity is a nice, easy thing to do in the laboratory. It doesn't take a whole lot of time to do it. Most meters are fairly standard. Mine is a 2-point calibration. Theirs looks like it's a 4-point calibration. So basically, the way this works is it's going to pass basically like a laser across and say, okay, how much gets received? The less it gets received, the cloudier it is. So that's kind of why it's important to look at your standards. And they noted on here there's going to be a date on the standards for which they're applicable. It's good, if you're expired, it's good to go ahead and redo it for what we're doing today. We're not doing a research project, we're just trying to teach you. It's perfectly fine. When you do these important things, okay, so light's got to pass through this, right? What do I not want to do if I'm picking this up? I don't want to grab it down here and put my fingerprints all over it, because if I put my fingerprints over it, I'm going to change what it is. The other is, be careful with what you wipe these off. These cloths are made to go on like your eyeglasses and things like that. They're not going to scratch. You do not want to scratch these. So don't just grab a paper towel and start wiping away on it, because then you're going to have problems. And usually when you wipe it, they tend to go in one direction. Okay? The other important thing is, on top of this, you're going to see a cap, black cap. It's very important because this sensor is reading light that you don't let more light get in, because that's going to change your reading, okay? So what they have done is we've kind of run through the calibration again. Each of these are a little bit different, but you should calibrate these each time before you use them. It's really quick to do. And then you're going to have additional sample vials in which you can put them in. So here's the vial here. It has a little white line. You need to fill at least to the white line or a little bit above. The other thing is, and Alan asked me if I'd done this, is shake your sample before you do it, because we collected this and it's set, so we don't want to let everything go to the bottom. You do enough of these, you'll start to get an eye for what it is. I don't know how high your turbidity meter goes, but some of them have a maximum range they can do, and I'm guessing yours is about 800 since it's where your standard is. If it's above that, you need to dilute it. And so usually you'll do a 1-to-1 dilution first, and then you'll have to correct that once you get it back. Because if it's too cloudy, it's not going to work.
Is the dilution linear? In other words, if you dilute, do you get a linear response?
Most of my samples I don't have to dilute. Some of them we've got off the mine, we have, but I usually don't have to dilute. Once I get about 800 on mine, above it I have to dilute, but a lot of them I haven't. So I've never really tested it where I've diluted everything to see if I get the same relationship. It's a good question. I don't know. There might be something out there on that. All right, so I'll let somebody do this. Anybody? Takers? Come take. All right. So basically, you're going to fill this one vial up, and we can do a few of them this way if you want. The other very important thing is all turbidity meters are a little bit different. So if you start a research project with a certain type of turbidity meter, stay with it throughout the entire project. And when you write your results up, it's very important that you tell them what kind of meter you use. Because I can use this meter and another one may give me slightly different results, okay? So here's your vial. So you shaking it up, you just want to carefully pour in until you're a little bit above the white line. We'll screw the cap on, and then we'll wipe the outside. Yeah, well, afterwards. Afterwards, because you're probably going to pick the vial up. You can pick it up. There you go.
But it is still underwater, neutral. When we use some portable equipment, during it always calibrate in every place we measure the.
So, like the turbidity meter, if you're using a portable, you should be fine if you're doing it all within one day. But calibration on these things usually takes just like a minute. And so in my lab, we just calibrate it every time. Because it's not like a long calibration process. It's just put it in, go a little bit above the white line. We have plenty of sample. Don't worry about wasting it. Yep. All right. I'm gonna drop my turbidity number. I'm gonna say. I'm gonna guess 80.
You can't change it after you see the smaller sample.
All right. Now screw that in. These are chem wipes. So there's like screw that one over the top, and then this in one direction. And then once you get that, go ahead and set it in. It's gonna just hug it a little bit. It hugs it good. Now put the cap on, and then hit read.
And what kind of water we use to calibrate the?
You buy standard solutions from the manufacturer. So all these are standard solutions from the manufacturer.
24.
And
We're way off.
no,
it's lower than I thought it would be.
in my department we have 1% of turbidity, and there is no dilation solution to calibrate.
There should be. Everyone I've